In this video, we are going to conduct a very quick and simple ABC analysis with Microsoft Excel and Power Query. Our data is stored in a CSV file and it is potentially large. You have to know that Microsoft Excel has a limit with respect to the file size it can import. So if we had a file that has more than 1 million rows, we would not be able to open it directly in Microsoft Excel. There's a very convenient way to work around that limit, and that is through Power Query. If you don't know Power Query yet, you should read about it, you should watch a couple of videos. It is a really useful tool to get and transform data, including large data sets that you could otherwise not work with in Microsoft Excel. So let's go to the Data tab and click on From Text CSV. And my demo data is in this folder here. It's a CSV file. I click Import. Excel makes a couple of assumptions about the data set. For instance, it guesses what character set is being used for the data set. How is it encoded? And in this particular case, this is Western European, which I know to be correct. Then it assumes a delimiter. Whenever we work with CSV files, we have to define the delimiter by which we have separated the different columns in the file. Sometimes that's a tab, sometimes that's a comma, and CSV stands for comma-separated values, so this is very common. Sometimes it's a semicolon. In this particular case, it's a semicolon. And then, before we continue and simply press Load, we want to click on this very small little downward pointing arrow here, and instead of selecting Load, we select Load To. And here comes the important part. If we simply click on Load, or if we click on Load To and we leave the settings as they are and click OK, then we would try to import the entire data into our Excel table, into our Excel sheet, which, as I pointed out earlier, might not be possible because of file size limitations. So in order to be able to work with very large data sets, and also in order to not inflate the data size of my Excel file, I click on Only Create Connection here. And what this does, it basically creates a pipeline between Excel and the original data set. And the original file, the original data set, will not be modified regardless what we do in Excel now. We only create a connection. And this is kind of a read-only relationship. So I click on OK. And on the right-hand side, you can see that this frame has opened that is called Queries and Connections. And I can see the connection to my order data demo set here. If I now double-click on this query, my Power Query window opens. This is the Power Query editor. And this is a very useful tool that many people have never heard of. And I would say it's one of the most underappreciated powerful features in Microsoft Excel. It's also a kind of gateway drug to Power BI, because Power BI and Microsoft Excel, they use the same Power Query editor. So the procedure, the first initial steps for data analysis is the same regardless whether you use Power BI or Excel. Before we perform any data analysis, we should always make sure that all columns are of the correct data type and that our data is valid and plausible. For the sake of brevity, we will skip the validity and plausibility checks here and adjust the data types. The order ID column is of the data type whole number, which is not what I want. I want it to be in text format. I replace the current step. And the same applies to the SKU ID, which I want to be in text format. The data we have are order data from a warehouse. There are different types of ABC analysis that we could perform. We could examine how often certain items are ordered, or we could analyze the quantities in which they are ordered. If we had the monetary value of the products in our data set, we could also base the analysis on the product value. But we don't, so we can't. In this video, we are going to do the ABC analysis based on order lines. We want to find out which products were the most popular and which were the least popular during the observation period. So we have this column here, SKU ID, which contains the unique SKU identifier. And on the right-hand side, we have the quantity. We don't care about that column. We have order ID. Here we don't care about that column. And we have the date. We also don't care about this column. So the only column in this data set that we care about currently is SKU ID. And we would like to understand how often each SKU ID appears in this column. And this is how we do it. So there's a very important function in Power Query that is called group by. And we find it in multiple places. We find it in the Home tab here behind this group by button. We can also go to the Transform tab, and then we've got a group by here on the left-hand side. Group by is not unique to Power Query. It comes from the database world, and you can use it in all languages and tools that are able to aggregate data. The group by function is used to group rows in a table based on the values in one or more columns, and then perform aggregate operations such as sum or average or count distinct on other columns within those groups. This is very useful for summarizing large data sets to extract meaningful insights. Before I proceed with grouping and counting, I want to make sure that my original data query remains unchanged, in case I want to perform additional analyses later, or perhaps filter out some SKUs that I've learned are not relevant to the analysis, such as packaging material. There are two ways to continue with the analysis while leaving the original query unchanged. I can create a duplicate or a reference. A reference creates a new query that points to the output of an existing query. This means that the new query is dependent on the original query. If you modify the original query, the changes will propagate to the reference query. A duplicate, on the other hand, creates a completely new copy of the existing query. This new query is independent of the original query, which means changes to the original query will not affect the duplicate query and vice versa. In our case, we want to create a reference, because if we change the original query, we want all changes to propagate to our analysis results. Let's quickly rename the resulting reference query. I will call it ABCOL because it will contain the ABC analysis of order lines. Then I click on Group By. I select the SKU ID column as the Group By column. And then I have to decide what I want to do with all the other columns or with the results column. And what I want to do is I want to count the rows. And as you can see here, I cannot specify which rows I want to count because, well, all columns have the same number of rows, so it doesn't matter. The resulting column I will call OL count, so that I know this is a count of the order lines per group. And then I hit OK. And that's it. And now I will sort the results column in descending order so that the most popular product, the product that has appeared most often in our order data, will be at the top. The next thing I want to do is I want to add the individual contribution in percent to each SKU ID. So I go back to my original query and I create a new reference, which I will rename to OL total. And then I select any column in this query and I go to Transform, Statistics, and I say Count Values. And what this does is it counts the total number of rows in the data table, which is the total number of order lines. Now I go back to my ABCOL query and I say add column. The add column tab is up here. I say custom column. And this new custom column I want to call percentage OL. And in this new custom column, I want to divide the column OL count by my newly defined variable, which I called OL total. And as you can see, while I'm typing, Power Query already suggests the name of the new variable. And I want to multiply all of that by 100 in order to get percent. Okay. There we go. Now we have for each SKU ID the contribution in percent. Just as we added a column with the individual contribution for each SKU as part of the total number of order lines, we now want to add a column with the individual contribution of each SKU as part of the total number of SKUs. So I create a new reference to our original query, order data demo, and I rename that one. I will call it SKU total. I go to the transform tab. I select the SKU ID column. I go to the statistics functions and I want to count the distinct values. Please note that in the previous example for the contribution of order lines, we simply counted values. Now we need to count distinct values because we want to understand how many different SKUs we have in that data table. There we go. So in this example, we have 3,910 unique SKUs. Now I go back to my ABCOL query. I want to add a new column, custom column. And I want to add a column that is called percentage SKUs. And this computation is very simple. I want to divide 1 by the total number of SKUs, which is stored in the variable SKU total. And I want this to be in percent. There we go. All right, very good. Now, based on these two columns, percentage OL and percentage SKUs, we can now continue and create a running total for both columns. We could create the running total directly in Power Query. However, this is a bit painful, and you can find a lot of videos on YouTube that explain how this works, but I can tell you it is comparatively complicated, surprisingly complicated, and I do not know why Microsoft made it this complicated. Anyway, I recommend we skip that and we close our Power Query editor and continue in standard Microsoft Excel. So I click close and load, and that will close the editor. If the ABCOL table doesn't load automatically into a new Excel sheet, you right click on the query here on the right hand side, you say load to, then you select table, and now you can decide whether or not you want to add the data to a data model. We don't need this for our purpose. If you want to continue with other analyses in Power Pivot, you may want to add the data to the data model, but we don't need this, so we leave this box unchecked. I want this data to be in a new worksheet, and I click OK. You can see how the data is loading here on the right-hand side. It's quite some data that we process, so this may take a while. There we go. Right, now we've got our aggregated data table in a spreadsheet. And we can do all the spreadsheet work that we are used to in Excel. Now the difference is the data in this spreadsheet is formatted as a data table, which means that you can only have one formula in a column. And this can be very convenient, but it can also be a bit annoying, for instance, when you're trying to create a running total, as you will see next. Now, in stock Excel, creating a running total is actually quite simple. So normally what you do is you take the first individual value. So we can say H2 is the same as C2. And then we always add the previous value to the next value. And then we can pull down that column. And you can see how the running total builds up. Now, if you're directly adjacent to the existing data table, then you can simply double click in the bottom right corner and it will automatically populate all the other cells down to the last row of the data table. Now the problem here is this. If we want to do this here directly adjacent to this data table that is formatted as a data table in Excel, in the moment we assign the cell E2 the same value as C2, it will populate all other rows with this cell is equal to this cell, which is not what we want. Actually, what we want is in E3, we take the previous value and we add it to the next value. But this doesn't work. This doesn't work. This doesn't work because it's a data table. And in a data table, you can only have one formula at a time. So we need to find a workaround where we can have a fixed starting point and a dynamic endpoint for the summation of the values. You may wonder, why don't I just pull down the formula in the column H down to the last row? And I could do this. And of course, I will not pull this down manually. I will say Control Shift and that would bring me to the last row. So if I copy the formula like this, Control Shift and I will be at the last row of the data table. I can say paste. And then if I look at this, I can see, yes, it adds up to 100%. So this works. This works. But in this case, then we have a formula, we have a column with a formula that is separate from our data table. It's not a big deal. We can work like this, but I would recommend something that is a bit more integrated with the data table and can make use of all the advantages of the data table, such as growing automatically. Imagine you import a new file, and this new file has additional SKU IDs. So that means that our data table in the query and also then in our Excel sheet will be larger. It will be longer. It will have more rows. But this separate column H will not grow with the data table. It will stay where it is. The values will update, but they will stop at the original row count. If we want the running total to be always up to date and to be accurate, then we need to connect it directly to the data table. Okay, let's do this. So we go to our newly created column E right next to our existing data table. And we've tried to do something here which didn't work. So let's rename this column first. I call it running total SKU. And the puzzle that we need to solve is that we want to add up values in this column. And we need to have a fixed starting point, which is the first value in whatever column we want to add up. But we need a dynamic endpoint. And the solution to this puzzle is that we nest the index function within the sum function. The index function in Microsoft Excel is used to retrieve the value at a specific position within a range or an array. And it is useful in situations where we need to look up data based on row and column coordinates. We can use it in our data table to refer to a fixed starting point in the sum function. So let's try this out. I select the first cell in our column E and I include the sum function. And within the sum function, I want to include the index function. And the first parameter of the index function is the array in which I want to look for a value. And that will be our column D, and that is called percentage SKUs. So I use squared brackets, and then I can select percentage SKUs, and I close that bracket. Then I want to take the first value from that array, so first row, and then that is our index function. I close the index function, and now I need the second parameter for the sum function, so colon, and then I want to use as an endpoint for the sum function whatever row we are in within that column percentage SKUs. So I open squared brackets, I use the add symbol, and then I select percentage SKUs again. I close the square brackets, and I close the parentheses for the sum function. And that's it. Now we've got a running total for the percentage of SKUs. If this is correct, it should add up to 100%. So let's have a look. Yes, it adds up to 100%. Very good. So this is how we create the running total. And we will do the same thing now for the percentage of order lines. So we go to a new column, column F. We call this column running total OL. And we want to use the sum function again. Sum, and then index to get the fixed starting point. For the column percentage OL, first position, closing the index function, then the second argument for the sum function, percentage OL, and then closing this one too. And that gives us our running total for the order lines, for the percentage of order lines. And this is all the preparation work we have to do to conduct an ABC analysis. Now we can focus on the actual analysis. We have prepared the data, now we can try to understand the data. So one of the things we can also do is we can delete the values in this column. We don't need them any longer. So if we want to plot the typical Pareto chart, we will use this column F, which is the running total of order line contribution. So if we say insert and then recommended charts, we will already find that Excel suggests as one of the recommended charts, it's the Pareto chart. And you can see the typical shape of the Pareto curve. There we go. Now another question is, what do we do with that? And that question, of course, is tightly related to the reasons why we wanted to conduct an ABC analysis in the first place. Now, in our data table, we have all the detailed results of our ABC analysis. Since we have performed an ABC analysis of order lines, we can now see how many SKUs are responsible for which output in terms of order lines. For instance, we can see that the top 40 SKUs, which make up about 1% of the total SKU count, they produce about 5.6% of order lines. The complete and detailed results table is very helpful, and nothing can replace it when you need to make detailed decisions. However, the table can be quite long. In our case, we only have about 3,900 products, but sometimes we have 10,000, 30,000 or more than 100,000 different SKUs, which makes scrolling through the table a bit tedious. And in any case, the table is too long for a PowerPoint slide. And as you may know, many people are not receptive to information that cannot be condensed onto a PowerPoint slide. So we want to find a more compact way to present the most important information. Also, you've probably noticed that we haven't categorized our products into A, B, and C categories. So let's start by assigning our products to the categories before we create a more compact results table. The first step is to define the boundaries for our A, B, and C categories. Of course, we can define any number of categories like D or E or F, we could also include, but let's go for the 3 standard categories. The boundaries between A, B, and C products are not set in stone, and we can define whatever boundaries we find helpful. We could look at the graph to understand roughly where the slope changes and use these values as boundaries. But for the sake of simplicity, we will simply stick to the common recommendations and call A products those that make up less than 75% of cumulative order lines, B products those that make up between 75% and 90% of cumulative order lines, and C products all others. So let's go ahead and write this down in our Excel sheet. A has to be a maximum of 75%. B needs to be between 75% and 90%. And C, we want to be at least 90% of cumulative order lines. All right, so once we have defined the boundaries, we can go ahead and check with a very simple if statement, with a very simple if function in Excel, to what extent a product falls into any of these categories. So this we can do in the following way. We go to this column G, which is directly adjacent to our data table, and we include an if function. And because we have only 3 categories, the simplest is to check for A and for C. And if it's neither A nor C, then we can conclude that the product belongs to the B category. And the reason I'm saying this would be the simplest is because Excel is a bit primitive when it comes to if functions, and it can only check for one condition at a time unless we nest an AND function in the if function, and then we can check for 2 conditions. But it's simpler to check for 75% and for 90% instead of checking for 75% and 90% in one go. So now I go to the G column and I call this new column for our data table class. It will be automatically added to our data table. And now I will include the if function. If this value is less or equal 75%, and I need to make this a fixed reference, so I include the dollar signs. So that wasn't a dollar sign, this one is. Then this is an A product. And again, I want to make this a fixed reference, so I include the dollar signs. If it's not less than 75%, then I want to include a second if function. Well, if it is more than 90%, so this value is more than 90%, and again, we want to make this a fixed reference, then the product is a C product. And again, this is going to be a fixed reference. And if that is not the case, then probably it's going to be a B product. So this is the reference J4. And now we close the 2 parentheses. And that should be it. Now you can see that we've got 3 A products, 4 A products. We've got only 1 B product. And here we've got the rest as C products. And this doesn't make any sense. I made a mistake. And the mistake is very simple and it's quick to make. So we have formatted these values here as percentages, but we had already, before we did this, multiplied the running totals with 100. So instead of having 75% and 90%, which translates to 0.75 and 0.90, I need to format these as decimal values and simply write 75 90, 90, and 75. If you noticed the mistake as I was making it, send me an email. Next time I meet you in a bar, I will buy you a drink. Now this looks much more reasonable. In the G column, as we scroll down, we can see that we have a lot more A products, not only 4. So we can also, just to make sure this makes sense, count them very quickly. We can say we want to know how many products in the G column actually are A. And we can see it's 1,246 products. For B products, it's 618, and C products, 2,046. Okay, very good. So now we have assigned our products to the ABC categories, and this can be helpful if you want to make a management presentation, but actually it is not really a good basis for any decision. So what we can do instead is we can create a more compact results table, and I will show you next how to do that. In our results table, we want to list a number of significant markers that give stakeholders information about what the distribution looks like. So this is where we will place it, results table. This chart we can move aside. We don't really need that anyway. In our case, for example, we may want to show how many order lines are produced by 1% of SKUs, by 5% of SKUs, by 10%, 15, 30%, 45%, 60% of SKUs, and so on. And with such an overview, it becomes much easier to understand what we are dealing with. Let's now go ahead and define some important markers that we are interested in. So in the first column, we include the share of SKUs, and then next to it, we include the share of order lines. And we will begin with 0.5, 1, 2, 5, 10, 15, 20, 30, 40, 50, 60, 70, and let me put this down, 90, 95, 98. All right. So the way to do this is to use a lookup function. And those of you who share their office environment with Excel gurus, you have heard of lookup functions before. Everybody who uses Excel on a regular basis is familiar with the VLOOKUP. Now, VLOOKUP has a successor function in the more modern version of Excel, which is called XLOOKUP, which does exactly the same thing, but is way more flexible. And we are going to use XLOOKUP to look for those share of SKU values in our column running total SKUs. And then it will return the running total of order lines to us. Okay? All right, so I go to my column share order lines, and I add my XLOOKUP function. And now the lookup value is this one from the share SKU column. The lookup array is percentage SKUs. No, sorry, running total SKUs. The return array is running total order lines. If not found is a parameter that we do not need. We are looking not for an exact match, that's very unlikely. We can either look for an exact match or the next smaller item, or an exact match or the next larger item. I will go for the next larger item. And then we have to define a search mode, and we can simply do first to last, and then we close the function. And XLOOKUP returns for 0.5% of SKUs, 3% of order lines. And if we check this, let's check if this is correct. So 0.5% of SKUs, so that will be this one. That's the next larger item after 0.5%. And from the return value, we can see that this matches. Right? So this is 3.04% of order lines. So this is how we can do it. And we can simply pull down this function to all the other cells. And this is a results table. Now we can conveniently see that 10% of SKUs produce 36% of order lines. 30% of SKUs produce 72% of order lines, and so on. But wouldn't it be nice if we knew how many SKUs are 0.5% of SKUs? How many SKUs are 1%, 10%, 20% of SKUs? This would make it much more actionable. So let's include that piece of information. We click on Queries and Connections, and we open our Power Query editor. There it is. All right, so now in our table ABCOL, which contains the groundwork of our ABC analysis, we go to Add Column, and then we say Index Column from 1. Seems to be a big deal. All right, there we go. I rename this column to SKU count. And I will move it over here. All right. So then we go back to our Excel sheet. This needs a brief moment to update. This also demonstrates that Power Query, even though it is able to deal with data sets of pretty much unlimited size, well, it is not the primary choice if you value your time, because it becomes really slow with large data sets. This takes a split second if you do this in Python on the same computer, but in Excel with Power Query, this takes a lot of seconds. Okay, so now we have our index column here, SKU count. And let's move the share OL column in our results table over here to make a bit space. And we can add SKU count to this table. And now we again use the XLOOKUP function, and we want to retrieve the number of SKUs for the respective share of SKUs. Okay, so this is XLOOKUP. I look for this value in this column. The return array is SKU count. If not found, is not needed. I'm looking for the next larger item to be consistent with my share of order lines, where I also selected look for the next larger item. And I select search first to last, and that is it. All right, so now I can see that 0.5% of SKUs means the first 20 SKUs. Right? And the first 20 SKUs, they produce 3% of our order lines. And I pull this down. All right. And that is it. And this provides a much more detailed view of our results. And we can also see now that, for instance, if we wanted to reduce the load on our system by, say, 10% of our order lines, we would have to remove the first 79 items from the system, which is a very useful piece of information. Now let's make this look a bit nicer. So the results table will be a bit larger. We want to make sure that all columns are of appropriate width. Maybe we want to reduce the number of decimals a tiny bit because this is a bit too much. All right, and that is it. Now we have conducted a complete ABC analysis in Microsoft Excel with Power Query with a very large dataset, a dataset that has more than 1 million rows that we could otherwise not process in stock Excel. I hope you found this helpful. If you have any questions or comments, do not hesitate to reach out. Thank you.